You have it now? What's the pressure? One more, yes. Another. And it's still the same pressure as the beginning. Yeah. Okay, well. It's not gonna be that pressure, but if I change the pressure, then my decision. It's too dependent on pressure, you know, I can't change it. I'm not. Yeah. But I'm just trying to be sure, but like, what I'm not going to do is, the hell is that? It's the whole consideration. Well, I really didn't put that on pressure at all. Like, it's usually there's no sense of like layers. See, I did the shortcuts. I just for 10 minutes, it doesn't suppose. That's also. Well, I just still no, I'm saying over them. Yeah, that's all. I'm aware of them. But you have to yeah, that's it was fine. So yeah. You make anything else? That's great. Oh yeah. Well, that process was the board, right? Anything I'm just gonna run with it. It comes like 300 stuff. Hey, it's got a text of the big class web page, and the link is on that. Yeah, it must be the wrong thing. I just, yeah, I sent by text. I sent by text. Yeah, I can send it by. Yeah, you can just Google the class. You want, I'll send it. You want. No. You know what? It has, yeah. I mean, it goes to the class and then the top of the classes. But if your Zoom thing said the right thing, the thing's already open. So it isn't right. And then there's a passcode at the end. Maybe it's the passcode. Passcode is one. I've had that problem before. I've seen it before when it's on this lock. It wasn't even locked. Yeah, that could be. Yeah, that's probably true. Yeah, so you said he was yeah, it's something that's past me. Yeah. I see it back. Then there's, yeah, then at the bottom in the middle, there's like a Zoom, it says like Zoom.
Yeah. It's yeah, there you are. I got you. So something, I think the other one probably didn't have a point dot one at the end. Like the- Anyway, this one makes sense. All right, that's great. Hi. So, let's see, I guess I'll. Let's see. All right, so this is Amit Kulkarni from Avion. Yeah, let's see. Anyway, I guess, so Avion is, I know him because they make the color concentrate. They'll take a plastic and put additives in it, and then like if you're doing an extrusion process, you buy these pellets with the concentrate in it, and then instead of getting bags of pigment, you buy this stuff and put it in to get the stuff to be yellow or whatever color you want. And then also, I think you expansion for foams and things like that. So basically, maybe you could just talk about a little bit, maybe whatever. What do you guys do? Did you hear me? No, you can't hear me. All right, that's
Hey, good afternoon. Can you hear me?
No, yeah, I can hear you, but you can't hear me. My mic is on. I think you're, I'm not muted. Audio should be fine, probably.
Hey, Raj, can you hear me now?
I can hear you fine, but you can't hear me. Okay.
I can hear you now.
Oh,
So
you can? Oh, okay. All right, maybe I clicked something. Anyway, so you're, so you can kind of see the class with it. I have another computer set up, so.
okay.
So, anyway, so yeah, like what does Aviant do? I guess something, oops, it just shrunk you. That was even worse. That's good. Can you hear me or?
I can hear you.
Yes, what is maybe you could just say like what the.
Yeah. So help me with the logistics, Dr. Beaucage, but starters, thank you for allowing me to join the class. So good afternoon, everyone. My name is Amit Kulkarni. I'm currently the Vice President of Innovation at Avient Corporation. We're on the opposite end of Ohio from all of you. We're here in Avon Lake, Ohio, which is essentially a Cleveland suburb. But I don't know, I'm dating myself here about, what is that, about 18 years ago. I sat probably in a class similar to you. I'm a Bearcat too. Worked with Dr. Beaucage on my PhD in 2002 to 2007. So glad to join you guys. And at Avient, again, we are a global provider of material solutions. And we have a pretty broad portfolio of advanced polymeric, composite, as well as additive solutions that we sell into a broad array of markets and industries. So from food packaging to automotive to aerospace to the list goes on. On a very high level, we have a pretty significant portfolio of functional additives and colorants that we sell into plastics, fibers. You can pretty much think about a pretty broad range of applications. And then on the engineered materials side, we have a pretty broad portfolio of specialty formulated engineering thermoplastics, elastomers, composite materials where we make both thermoplastic and thermoset composites, as well as we have a pretty significant footprint in composites used in protection or ballistic applications. So think about not fireproof, but bulletproof vests and helmets for law enforcement applications. So that's who we are. And we're primarily a formulator and an application development focused company.
Yeah, so so this class is about sustainability or circular economy. I noticed you have like this, when you go to your webpage, the first thing are like 3 links for sustainability.
Yeah.
Seems like that might be some kind of interest in that. But anyway, so I'm wondering how, so I mean, additives is part of what you do, right? That
Mhm.
that seems to be like the main bottleneck with a lot of recycling processes, especially pigments and
Mhm.
separating pigments from a plastic in the
Yeah.
process, so have you solved that problem today or?
Sure. No. So no, so we definitely, so I'll probably talk a little more holistically, right, about it, Dr. Bokaj. Um, so A, um, if you think about sustainability, and there are various flavors of being sustainable, we can definitely talk about recycling or providing solutions that enhance the recyclability of materials. So, kind of, let's think about the simple PET water bottle, or a, a soft drink bottle. Um, you really have a extremely engineered product. It's not just a container. Depending on what is being packaged, the technology that goes into packaging that said material provides shelf life to whatever is being stored and sold across the globe. So there is sustainability associated with providing food to our 8 billion co-inhabitants. So there is obviously that. Um, when I call this an extremely engineered product, it's not just a plastic bottle. There are specific ingredients in there that extend the shelf life of that product by either being a barrier or a scavenger for certain gases that might ingress into the bottle and spoil that food source. Um, so obviously, on the flip side, having those ingredients in there could then potentially pose challenges when it comes to recycling that bottle. Um, Obviously, a lot of the brands have now mandated some pretty significant percent recycled content that can be incorporated into these bottles. So I don't know, it's probably how many like Diet Coke or Diet Pepsi drinkers in the class here. If you've seen some of these more recent bottles, you see that. I mean, they do market that they're 100%, they're made out of 100% recycled PET, and you can see how discolored they are, which is fine as long as as the consumers are fine with that. But then again, and this is kind of both an engineering and a chemistry challenge, right? So if you're going to incorporate certain additives that are going to scavenge oxygen so as to preserve the food source, great, but that makes recycling a challenge because when you recycle it, whether it goes through uh, either maybe more so physical, there is going to be heat history, and those additives are going to cause um, additional yellowing or color formation in the recycled stream. So more recently, like, how do you then solve this challenge? You need that oxygen barrier first and foremost to preserve the food. But on the flip side, you also want to recycle that bottle. So instead of putting that scavenging or barrier technology in the body of the bottle, could you move it from the body to the closure, right? So that's something that we've done recently. So that's where I say it's both a chemistry and an engineering challenge. Um, Also, it's not just about scavenging. It's also about, if you think about PET, providing specific functional materials, um, at the end of the day, what happens to a polymer going through repeated heat histories? It basically loses its mechanical performance. Why? It's basically losing its molecular weight. So again, providing functional additives that can then allow recyclers during the recycle process to build up that molecular weight again. In certain cases with the polyolefin recycling, it might be the other way around, where you want additives that reduce the molecular weight so that you can use it in a broader array of applications in the second go around.
Oh, so
There
you're
are,
designing, so you're designing additives to go into the recycle stream to improve the performance of the regrind or whatever?
absolutely. And then also, if you think about the recycled stream, a simple thing like recycling PET is a multi-stage process, right? Including an initial step where you're granulating the PET. And guess what? One more recent challenge that's coming up, and it'll come to the North American shores, but definitely a big push in Europe. PET, the bottle is PET, but there is a label on that bottle. And what do you use to stick that label onto the bottle? Some sort of a glue. That comes along for the ride when you recycle it. And some of those ingredients used in the glue are bisphenol A based. And there is enough literature out there into the health impacts associated with BPA. So again, providing additives that can scavenge that bisphenol A so that the recycled stream doesn't get contaminated with BPA. But there are strict limits around BPA content. I mean, we want no BPA, right? I mean, especially in Europe, they want non-detect BPA. We're definitely talking parts per billion, not parts per million, as being the allowable limits. So again, providing solutions for that. Another area around the recycling cycle, Dr. Bukaj. Yeah.
BPA was kind of like polycarbonate, but I guess you're saying it's in other things too. Huh? I mean, it's a
I mean, so by the way, think about all the lining in your canned goods. That is still BPA based. Yes, there was a big push. And by the way, it just so happens back then I used to work for a company that made polycarbonate. The big push was around those big polycarbonate water bottles or baby milk bottles that were polycarbonate. But BPA does still exist in a lot of different things.
Sabic in Indiana for a while, right? Yeah.
Yeah.
I think some of you guys did Sabic for co-op, right? One or two were. I think someone in here did. I don't know. Maybe they're not here. Anyway, somebody does that. But yeah, that was a long time ago. But yeah, I don't know what they're doing. They must have the same kind of push going on. I guess all the industry is pretty much highlighting that ability, but who knows if it'll disappear with this new administration? I mean, I wonder if that was something that we had in the past, but anyway, yeah, that's pretty good. So, but you guys do PET work then, or at Avient?
A lot of it in terms of providing solutions that enhance the recyclability of PET. We don't make PET, right? But definitely part of the value chain in terms of,
Looked at the kind of the history of the company, you know. All right, so we had someone come from this guy Kelly from what was the name of that company? They make PLA film, you know, in Ohio, in Cincinnati, or yeah, I think maybe in Columbus or something. But but anyway, he was saying how like the big thing is like the consolidations of companies, polymer business, you know, and that how that's kind of impacting a lot of this. Somehow it's impacting. So anyway, I looked up your company, you know, briefly. And it seems like you guys have gone through a lot of, and if you want to talk about consolidation, it looks like Clariant getting that, and then some of the other companies purchasing. So it seems like part of what your business is like consolidation is becoming a big thing, right? I mean, wondering how that impacts this whole recycle picture.
Well, So rather than thinking about it as consolidation, I think, and this is me speaking, right? And I'm not representing or making an official statement here.
Yeah, yeah,
Yeah, no, but like if you think about the traditional, if you go back like 30, 40 years, um, some very traditional companies that you would think of as polymer companies are no longer doing polymers.
right.
I mean, think about DuPont, like they've sold off their nylon business, or DSM, they've sold off their polyolefin, nylon, pretty much anything to do with polymers. And that to me is purely driven by like economics or whatever corporate vision they might have. They might be trying to recast themselves as a ag company or a biotech company, or in certain cases, there are people who have gone into consumer goods, etc. So it's not so much consolidation, it's just kind of shuffling of the deck, if you may. Because none of those business, I mean, all those businesses are still active, just
Yeah.
under some new brand name,
Well, a
right?
lot of it's in the
Yeah.
like in the commodity sector, right? So it's not
Yeah.
so much specialty polymers, but you guys do quite a bit of specialty polymers, I think.
Yeah.
Yeah, so the commodities business, that goes through, it's almost like a fire sale for the business sectors, you know, it's kind of crazy. Every couple of years and the whole big company like Shell or something just gets bought up by Lyondell or something, and you know, everyone's shuffling around. I mean, I went back to a plant, like I worked at a plant in Frankfurt, you know, and it was Hearst when I was there. And now it's Lyondell Bazell.
Yeah.
It was Shell for a while, you know, so it's kind of like the whole plant, which has a long history back before,
Yeah.
like back to turn of the century 18 and 1900s. Like
Yeah.
that, they don't care about history. It's just like sell the thing and move on, you know.
No, but if you think about maybe a positive outcome of that, um, one of the routes towards sustainable materials is potentially chemical recycling. Obviously, there are people with lots of opinions and calculations as to how green it is. Regardless, for chemical recycling to be a viable route, you need scale. Like,
Yeah.
right. I mean, the larger scale that you are, the more better both the economics and the footprint associated with that process looks. So maybe especially on the commodity end of plastics, maybe that consolidation helps with more of a chemical recycling footprint. And then there definitely are companies, right? I would look at like a Eastman, who's made a big bet around chemical recycling and has invested billions in creating that infrastructure for chemical recycling. So again, this is just conjecture as to whether or not the consolidation of erstwhile chemical companies, polymer companies leads to something that's positive from a sustainable impact perspective. So um, that's one possibility.
I mean, it's reduced in competition. I mean, that's for sure. And usually you think a competition is a good thing. On the other hand,
Yeah.
you're right about scale. Like if you wanted this, especially the chemical recycling, you
Yeah.
can't small scale.
Yeah.
So it makes sense putting it that way. And
Yeah.
if additives, the chemical recycling is definitely the easiest route, right? And maybe the only, right? I mean, if you want to get rid of the BPA in the label, you can do it by distillation, you know, it's some
Yeah.
chemical recycling step. So it makes sense that, anyway, it does seem like the energy analysis for it is a little bit missing, you know, like
Yeah.
like how much energy does it take to go through that route compared with, so without regulation, which we aren't going to get, you know, it's basically hard to believe it. It's not an economical process sometimes, you know. Maybe sometimes it is, but
Yeah, but at the end of the day, right? I mean, I won't comment about regulations, but from a corporation perspective, and I'm with you, right? In terms of truly understanding whether or not the process actually is net positive impact from a sustainability perspective. But definitely from a corporation perspective, if they're going to invest billions of dollars, they would, at the end of the day, it matters what you're chemically recycling and what is the end value of that chemically recycled and upcycled polymer or material. So I probably have higher confidence on the economic value being created. If not, then that would be a bad business model and would fail. So, but definitely acknowledge that understanding all aspects of whether the chemical recycling route is truly better for the environment, it's not a trivial question to answer.
Yeah, I guess until there's either a regulation or a litigation, then there, or maybe a PR issue for some companies, you know.
Mhm.
There isn't really any way to get companies to do something just because it's a nice idea.
Yeah.
Right, so basically the system isn't, it's got some outlets to make it happen, but we're not in Europe. So it's like we aren't really seeing the kind of change that they have, I think. But, or even China, you know. So I think you guys operate in China or,
What I would say is we're a global company, but like at the same time, I think the economies are getting pretty interconnected, right? So things that happen in Europe eventually do impact other regions, given that, again, we go back to scale. Like, if certain regulations in a commercially relevant region, like all of Europe, force us to or require us to go do something, again, from a scale perspective, we may want to replicate that everywhere. But you're right. Europe definitely tends to take the lead in terms of setting up those regulations. And then we have definitely in the space of green chemistry seen other regions follow suit, especially in Asia or emerging economies where they don't have a rich history of regulations like the Western world. It's usually them adopting what they see either Europe or America is doing. So again, I think it's getting to be a more interconnected world where, again, regional policies and politics aside, I think the economies are getting, or should hopefully get, to a point where we have consistency in how we are attacking these problems.
I mean, in China, don't they have, I thought they had pretty good regulations on environmental.
Very good regulations, especially with regards to materials. You take, for example, in an automotive or automotive emissions, I would say probably more stricter requirements on what materials and how they need to perform in those applications.
But you sell in that market, right? I mean,
We absolutely sell in that market.
What cut is it like of the, so you're mostly, it sounds like you're mostly US and then some Europe and then a little bit of China or?
Yeah, like so I would say probably 40% Americas, 30% Europe, 20% in, I would say, broader Asia.
I guess they control their markets too. Like they, in other words, it's harder to enter there because of the government supports the local businesses, I think, but.
No, say, I mean, if you think about most American multinationals, they have a significant footprint in Asia, right? And at the end of the day, for no matter who you are and where you are in your journey, the future demand associated with that continent would require every business to take that region seriously.
Yeah.
Yep.
So do you guys have any questions or comments or anything? Sorry, I'm dominating, but it's kind of like meant to be a discussion. So, yeah.
What's the most interesting additive or product you guys make at Avian?
Could you please repeat that? What's the most?
What's the most interesting?
What's the?
What would you choose?
What's the most thing that you would tell your kid about? Bulletproof helmet. It's like this, we can tell like your mentality by what this answer to this thing is.
So I'd say, so, okay, I'll start with this, right? So we have, on last count, we had more than 45,000 products that we made. So again, difficult to say which one is the most interesting. I would say maybe I won't. How about this? I don't cheat, and I still do give you an answer. But maybe we create 2 or 3 markets, right? And because how do you really compare different markets and their requirements? So I would say, let's pick. If we were to pick, let's say the healthcare space, we have some really interesting elastomers that we sell in the manufacture of biopharmaceutical materials. And I find it interesting. At the end of the day, biopharmaceuticals are just some polyethylene reactor bags connected by tubes, where they're making large molecular pharma. And obviously with cell and gene therapy, I mean, that's going to revolutionize the future of medicine. So, but purely on an application basis, it's just a tube, right? It's an elastomeric material that's been extruded into a tube. But again, from an engineering and a chemistry perspective, it's a pretty complicated application in terms of what it needs to do, in terms of the temperatures it needs to operate, in terms of its biocompatibility, in terms of the adhesion or lack thereof of some of those proteins that are being synthesized to the walls of that tube. So that's really interesting. And again, given the application and the future of the healthcare space, right? Especially with cell and gene therapy, where there is the potential that there is a customized drug that's manufactured for each and every individual based on their genetics. And it's so effective, obviously. I mean, that's way out into the future. So I'm really, I find that fascinating. So Dr. Beaucage mentioned bulletproof helmets. So that's absolutely a feat of engineering, right? If you think about it, what we make it out of, the basic molecule is polyethylene, right? So I mean, that's your grocery bag. I mean, that's the material that we can convert into essentially bulletproof helmets for law enforcement. So I mean, that to me is just a feat of engineering that's quite phenomenal, to take a simple molecule like polyethylene and convert it into such a high performance material. Yeah.
Do the processing for that, or I thought that was DSM that came up with that, right? I think.
Yeah, that's a part of Avient now, Dr. Beaucage.
Yeah. So did you buy them or something, or like?
Yeah, we acquired Dyneema in 2021. Yes.
Yeah. DSM was like the big. It's Dutch, right? Dutch state mine.
Yeah.
That's like the biggest chemical company. One of the, so you just consume things like that. It's like the octopus. Right. Yeah. Yeah, that's pretty interesting.
Yeah.
Any other things that?
So you talked a little bit about the additives towards like colors and stuff, but do you have any examples of additives for maybe other like actions? Like you were talking about the oxidation or oxygen from getting in. Can you just talk more about those a little bit?
Dr. Beaucage, sorry, it's a little difficult coming in. So additives in what space again?
Well, we know about pigments, and we know about that there's an oxygen scavenger, but you didn't say what it was. and then I guess there's blowing agents, and then oh, flame retardants. What about flame retardants?
Yeah, so when you think about oxygen scavenging, I mean, it's really a reactive system. It's based on some flavor of butadiene complexing with a inorganic molecule and them coming together to trap or react oxygen and scavenge it. So, and obviously there are other technologies. Um,
So it's an oxidation reduction reaction with the metal
yeah,
or
essentially,
chelating agent.
yeah, like it's a metal oxidation reduction
Okay.
process, right?
Yeah.
So that's more around oxygen scavenging, but talking about other applications for additives.
Well, the flame retardants with the brominated flame retardants, do you deal with those?
So, I mean, we do make certain flame retardant packages. For the most part, I would say the industry is moving towards non-halogenated flame retardants. And then again, most of this really is around synergistic effects of phosphorus, nitrogen compounds. I mean, which finds a wide variety of applications from building and construction to consumer goods. And I would say we have a not so trivial portfolio of flame retardant materials, but again, we're not making flame retardants, right? There are specific companies like, I mean, many of them that make that chemistry. We are again formulators looking at which of those combinations provide more impactful performance. Those are some part of some of our additives. But then again, we have additives that go into a lot of packaging applications, where we have this brand called Smart Heat, where kind of incorporation of our additive at like parts per million into your process. Let's say you are producing sheet or blowing bottles, that reduces your energy consumption by like 20-25%. So again, this is kind of a thermal conductive additive. So I mean, during COVID, we made some additives that, I mean, we already had those, but we had to redesign some of those that were electrostatically active and being utilized in filtration masks for COVID. So again, I mean, it's there is no, I mean, as I said, 45,000 plus products, right? So a lot of different, I would say, functional additives, right, that get incorporated at extremely low levels in the fabrication of any part or device. Yeah.
You guys do UV absorbance, right? Too, like for outdoor applications.
Right. So again, right, I mean, if you think about UV, the basic chemistry of a UV absorber that's being supplied more like by a larger corporation, like a BASF, right? But they make like one flavor of a UV absorber, but then where we come in is how do you make it more efficacious? Can you combine it with other chemistries, deliver it in a different way, which can bring more customized value based on that application or market that you're going after.
I mean, because you could just use carbon black, right? But people don't want to have a black thing, I guess,
There
mostly.
you go. Right. So
So
like
basically,
yeah.
in organic chemistry and
Yeah.
But those things are they toxic, or I guess none of the UV absorbents are really toxic, are they? Or I don't know.
Obviously, depending on the application, there are strong toxicological limits, right? At the end of the day, when we think of any material, above and over a certain limit, anything can be toxic. So really understanding what are you designing for, what is the proven science in terms of product stewardship and the regulatory limits. And also, right, I mean, if you get into medical applications, it's not necessarily just about what you put into your material, but what can leach out of your material depending on what medium it's getting exposed to. So I would say, definitely I'm not an expert or a toxicologist, but definitely from a product development perspective, really having to understand all those aspects is pretty important before you put a product out there into the market.
Do you do like medical testing at your company, or that would be like the user, right? That would do that, or?
Definitely, our customers would probably be the one who'd have to take their device and get those through those FDA. But then again, right? I mean, we have to strongly partner with our customers um, to help them navigate, and also at the end of the day, we are the material experts, they are the application and market expert, and those two things have to come together to realize that. Um,
For a given product like the tubes, I mean, you make up a team then of different companies that work together to try to develop the product? Is that how it works, or? But you'd have
yeah,
a
so
supplier, your polymer supplier in with it too, right?
right. So I mean, at the end of the day, it's the entire value chain, right? There's someone who's making a basic chemical. Uh, the same person might be converting that to a polymer or an additive. We sit kind of right in the middle, right? In terms of like taking all these different ingredients and formulating with those. But then let's think of a brand, right? Now you mentioned medical, so let's think of a Pfizer or um, a Medtronic, like a large healthcare focused corporation. Um, they are the ones creating products that you and I buy, right? They are really the B2C uh, business to consumer good provider. Uh, a Procter and Gamble would be one. All of you are sitting right there in Cincinnati. But again, they may or may not be manufacturing all components of how they put their product out into the market, right? I mean, if you're a Procter and Gamble, you're making soap in your factory, um, but you're not necessarily making that orange plastic box that your Tide pods go into. So that might be something that they are outsourcing to a tier one. So at the end of the day, it requires all of us to talk to each other to really know what is it that APNG or a Pfizer is trying to put out there to the consumers. So we're bringing the material science know-how, we understand raw materials, we understand how to put it all together and process it so that whoever's supplying that part component to a OEM like PNG can be educated and bottom line make it all happen.
Yeah, I think people don't have a grip on how the world works like that. I mean, it's surprising to think to most people that have one product like P&G Pods. There's an expert at that in here, but basically, I think they don't actually make those things. You know, I think that they just market the things, right? They maybe they came up with the idea and got the patent, but generally they don't make anything. I mean, that's my impression. They used to have paper companies, but I think they sold them because of liability. Maybe they have a couple, but I mean,
We used to have like the Joy detergent, I think, and then we sold that, but we had like a contract. I think it's probably. I don't know. So some things can make some things, I have no idea.
yeah, I think the majority of things, I think, and also I think the business model is to make less and less and just kind of market it, I think. I think that's the general trend, but yeah,
How do you know which kind of additives would contribute to the waste in the future? How do you anticipate that additive waste in the future? Due to laws which come in.
So the question is, which kind of additives would contribute to
No,
waste?
is there anybody thinking about it, and how would you?
Waste it can create in the future because you're looking into it. So how do you anticipate it or what?
Is there anybody there thinking about waste in the future? Like you make this, you have this team, say P&G wants to make some soap bubble thing. And then they are hiring someone to manufacture it. And there isn't, so the liability chain for one thing doesn't exist, I guess. I mean, it's hard to tell who has the liability chain if someone gets sued for the waste, I mean. And then like, is anybody in that chain, there isn't any environmental representative, right, in that chain, right? It's just like people trying to make money, handing off one thing to another, and no one's really thinking about, well, maybe the P&G people are thinking, because they're the end producer, right? So thinking about like, is it going to kill the fish or not? Is it a PP6 PPDQ from tires that just kills all the salmon? Like, is there someone there thinking about that?
So, I mean, I would say yes, right? And I'll give you some concrete examples and basically back up my answer. So, if you think about any corporation in North America, each of them, I would say, have very firm sustainability goals. And obviously, it's a pretty broad spectrum of targets that they're working towards. But like reduction of waste or waste to landfill is probably a common theme that you see across many of these companies. And also, a large B2C company cares about it because all of you care about it, right? At the end of the day, all of you are collectively demanding a more sustainable future. And that's important. I mean, if I'm not going to sit here and say, like, well, regulations have or don't have a place in this, we have to do our bit. And I think these companies, at the end of the day, will listen to their consumers. So they definitely have these sustainability goals. And then these large corporations, I mean, they hold a lot of sway in the value chain that supports them, right? At the end of the day, if a large customer or a large corporation that's tens of billions of dollars demands a certain level of performance when it comes to sustainability from people in the value chain before them, you will see that value chain aligning to deliver that solution. Also, from not necessarily regulation, but I would say I would definitely ask all of you to look up. Please don't ask me what it stands for, but it's called ISCC Plus, which is pretty interesting. It's kind of come up where it's really about that blockchain of if someone produced a raw material using a green source, they might have made a monomer, then that gets sold to someone who's going to make a polymer out of it, that gets sold to someone who's going to make a formulation out of it, that gets sold to someone who's going to process it into a part, that gets sold to a big company that is going to put their product in that part and sell it to the consumer. So ISCC Plus really kind of creates that blockchain of transferring and certifying the green aspect from molecule to product, and then closes the loop, right? So again, not going to comment on whether this should be mandated in the law by the government. At the end of the day, the economy itself is a big modulator of behavior, right? At the end of the day, if collectively the consumers are demanding for this, the market will align and try to satisfy that need. So definitely there are things that are happening that are moving us in that direction. And then in terms of, is anyone thinking about it? I would say yes, right? And whether or not going to sit here and argue whether they're thinking about it for the right reasons or not. Satisfying your customers' needs is a good, valid enough reason for them to do so. Because they are businesses and they exist there for a reason. And if they care about things that are important to their consumers, and as long as the consumers are thinking about the right things, this will have that effect of getting the value chain and the industry aligned towards producing a more sustainable future.
Is that what you asked, or I don't know if that,
Yeah.
It was more about anticipating the material which you're going to use for future recyclability and the future laws which are coming in, because it has to sustain for long time, decades.
Yeah. So I would say there is a big thrust, right? So for example, how do you choose materials? So one of the big challenges around recyclability, especially in packaging, would be the use of multi-materials, right? I mean, if you look at a simple film or a box, it's not really one material. It's like 5 or 6 layers of different materials providing different performance requirements. So I would say there is a big thrust towards going to mono-material construction, right? And this will require it, like material scientists of the world and still in school to come up with the next innovations. So definitely, I think there is a lot of thought in terms of developing materials that are inherently more sustainable, more recyclable. I would say there is a big thrust around understanding the carbon footprint of the materials that we use um, in a given application. Um, Again, there are probably big companies that are mandating that instead of just providing a technical data sheet of a product, you also provide the life cycle analysis and the carbon footprint of the materials you provide them. So now again, for every one example like where this is happening, there are probably 10 examples where it's not. But I'm a glass half full guy, right? So I would say yes, it's happening, definitely happening. But you as consumers have to keep demanding it, right? Because that's how the flywheel of our economy works.
Yeah. Anything else you guys thinking of there? Yeah, that seems pretty good. I don't know, it's I must have another question for you. I'm trying to think, but yeah, so so I think that so we've looked at regulation, we've looked at consumer movements, I guess, somewhat, and then litigation we spent a lot of time on.
Yep.
Like PepsiCo was sued by the Latita James in New York for the Buffalo.
Yep.
And then things are happening in California. So
Yep.
guys, do you have a lawyer? I mean, do you guys like you have somebody that keeps an eye on how litigation is going to drive the industry? You know, that's that. All right, in the US, there's no regulation. So basically litigation. So somebody must be thinking at your company about, is that how companies work? That they have someone that's kind of looking over and thinking, well, we could get burned on this thing seriously. And like the breast implant with Dow Corning, things like that. Well, they didn't have a lawyer thinking about it. So they went out of business, right? So things happen, right? And maybe the plastic waste thing is in the same category, or even the climate change, is getting to be in that category. So I'm wondering if that is driving it doesn't look like you're thinking about that. Adam.
No.
Okay.
So I won't say we're not thinking about it, but we're thinking about it for the right reasons, right? At the end of the day, there are emerging regulations, and we want to be making products that align with those regulations, because without that, you don't get to participate in business.
Nicer in Europe, because in Europe, with regulation, Europe doesn't have a litigious system, right? You aren't going to exactly get sued in Europe, but you get nailed with regulations. But it's a safer environment to do business because you know what the rules are at the beginning, and everyone's playing by the same rules. So it's kind of a fair competition zone.
Yeah.
And you know what you have to do. But in the US, it's a wild card zone. You could make a lot of money for a long time and then all of a sudden have the rug pulled out on you. Right. So it seems like Europe's a better place to do business, actually, because of the legislation, regulations. I mean, but I don't know.
Yeah.
I mean,
I won't comment.
I know you probably get shot or something, so it's like basically do whatever they say, I guess, in China. But then eventually they'll steal your ideas and whatever happens with that. But anyway, so yeah, I guess that's about it. I want to quit at 4:30. So my clock is old time, so it says 5:30.
Yeah.
Anyway.
Hey, no. So no, hey, really a pleasure talking to all of you.
Good to hear your opinions and stuff. It's like they can't get that kind of information like from a source. Get a feel for what people are thinking about. That's the only place you can get it. So why don't we thank Amit for
Thank you so much. Really appreciate it.
All right.
Thank you,
Anytime
Dr. Beaucage. Yeah.
stop by. So right.
Will do. Yeah,
We'll see you later.
take
Thank-
care. Bye.
Bye.